previous class we discussed about Bohr model of hydrogen and its limitation and Bohr-Sommerfeld model of an atom. Okay, so today in this class we are going to discuss about the quantum numbers. Each electron in an atom is described by the set of three quantum numbers n, l and ml. These numbers are called as quantum numbers. Each electron in an atom is described by the set of three numbers. They are three numbers. They are n, l, ml. These numbers are called as quantum numbers. These numbers indicate the probability of finding the electron in the space around the nucleus. Okay, so these numbers, okay, what are the n, l, ml? These numbers are called as quantum numbers. These numbers indicate the probability of finding the electron in the space around the nucleus. What information do the quantum numbers provide? The quantum numbers describe the space around the nucleus where the electrons are found and also their energies. Okay, so these are called atomic orbitals. What information do the quantum numbers provide? The quantum number describe the space around the nucleus where the electrons are found and also their energies. They are called as atomic orbitals. Around the nucleus where the electrons and what is its energy. About this quantum numbers will explain. Okay, so what does the each quantum number signify? Now we will discuss. Okay, so how many quantum numbers are there? 4 quantum numbers are there. What are that? First one is principal quantum number, that is showed by small n. Next, second one is angular moment quantum number, that is showed by L. Third one is magnetic quantum number, that is showed by ml. And another one is spin quantum number, that is showed by ms. About this each and every quantum number now we will discuss in this chapter. First, now we will discuss about principal quantum number. The principal quantum number is related to the size and energy of the main shell. Okay, so this principal quantum number is related to the size and energy of the main shell, and it is showed by n. Okay, this principal quantum number is related to the size and energy of the main shell, and it is showed by n, small n. N has positive values, means n is equals to 1, 2, 3, like that it will be there. As the n increases, the shells become larger and the electron in those shells are farther from the nucleus. Okay, if the n is increasing, the shells become larger and the electron in those shells are farther from the nucleus. If the n value is increasing, then the orbital size also increasing. Then the distance between the electron and the nucleus also increasing. Okay, then the distance between the nucleus and the electrons also increasing. Okay, so and increasing in n also means higher energy. That's n is equals to 1, 2, 3 are often represented by the letters K, L, M, K, L, M, N, like that. Okay, for each n value there is one main shell. For each n value there is one main shell. So the principal quantum number is related to the size and energy of the main shell. This n has positive integer values 1, 2, 3. As the n increases, the shells become larger and electrons in those shells are farther from the nucleus. As increasing in the n also means higher energy, n is equals to 1, 2, 3 are often represented by the letter K, L, M, and dash dash. For each n value there is one main shell. Okay, so this principal quantum number is explaining about the size and energy of a main shell. Okay, this is showed by n. Okay, So in this, so many main shells are there, no, that is showed by n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4, like that it will show. Okay, if the n value is increasing, then the shell becomes larger, and the electrons in those shells are farther from the nucleus. Okay, if the n value increases, means number of shells is increasing, then the shell become larger, then the distance between the nucleus and the last electrons are increasing. Okay, next, this n is equals to 1, 2, 3, no, they are often represented by the letters K, L, M, N, like that. Okay, so this small n is equals to 1, 2, 3, 4, like that is there, no, this also represented by the letters K, L, M, N. So for each n value there is one main shell. For each n value there is one main shell. Okay, here principal quantum number is related to size and energy of a main shell, no, that is showed by n. N is equals to 1. First shell is there, that is called as n is equals to 1 shell. Second shell is there, that is called as n is equals to 2 shell. Third shell is there, that is called as n is equals to 3 shell. Fourth shell is there, that is called as n is equals to 4 shell. Okay, so this, for each n value there is one main shell. What is that main shell? For example, n is equals to 1 is there, that we can call as a K shell. N is equals to 2 is there, that we can call as a L shell. N is equals to 3 is there, that is called as M shell. N is equals to 4 is there, that is called as N shell. Okay, like the different names is there. Means n is equals to 1, 2, 3, 4 minus 1, 2, 3, 4 means n is equals to 1 means K, n is equals to 2 means L shell, n is equals to 3 means M shell, n is equals to 4 means M shell. Like that also we can explain. Next we will discuss about angular momentum quantum number. It is showed by L. Okay, so this is angular momentum quantum number, or we can call this also as a azimuthal quantum number. It is showed by L. So this is proposed by Sommerfeld. By depending on the elliptical orbit, Sommerfeld proposed this azimuthal quantum number. It is denoted by n. For each principal quantum number, there are angular momentum quantum numbers are there. This L value will be there like this, 0, 1, 2, 3, 4, dash, dash, dash. So this L has integer values 0 to n minus 1. For each value of n, each L value represents one subshell. Each value of L related to the shape of a particular subshells in the space around the nucleus. The value of L for a particular subshell is generally designated by the letters S, P, D, F as follows. So the value of L for particular subshell is generally designated by the letters S, P, D, F as follow. Okay, so L azimuthal quantum number means this is explaining about the subshell only, no. If L is equals to 0, then that subshell name is S. If L is equals to 1, that subshell name is P, and L is equals to 2, that subshell name is D. Okay, and L is equals to 3, that subshell name is F, like that. So by depending on the elliptical orbit, Sommerfeld proposed azimuthal quantum number. Okay, this is also called as angular momentum quantum number. These azimuthal quantum numbers are showed by letter L, small l. These L values are start from 0, 1, 2, 3, 4. Okay, these L values are there like 0, 1, 2, 3, 4, like that it will be present. So this L has integer values from 0 to n minus 1. For each value of n, each L value represent the subshell. Okay, for each value of n, L value is represent the subshell. Okay, each value of L related to the shape of a particular subshells in the space around the nucleus, means this L value is represent the shape of a particular subshell around the space of a nucleus. So the value of L for a particular subshell is generally designated by the letters S, P, D, F as follows. For example, if the L value, L is explaining about the subshell, yes or no? So the L value is explaining about the name of the L value is explaining about the subshell, okay? N value is explaining about the main shell, okay? Principal quantum number N, that is explaining about the main shell. L value is explaining about the subshell, okay? So this L values are start from 0, 1, 2, 3, 4 like that, no? So if the L value is 0, then we can call that subshell name as a S. If L value is 1, then call that subshell name as a P. If L value is 2, then we can call that subshell name as a D. If the L value is 3, then we can call that subshell name as a F. When N is equals to 1, there is only one subshell with L is equals to 0. Okay, if N is equals to 1, in that only one subshell is there. Okay, that is L is equals to 0. Okay, and this is designated as 1s orbital. Okay, if N value is 2, there are only two subshells. Okay, there are only two subshells in that with L is equals to 0, that is 2s subshell, and L is equals to 1, that is 2p subshell. So if N is equals to 1, in that only one subshell is there, that one subshell value L is equals to 0, and that is called as 1s orbital. When N is equals to 2, means in second shell, in the two subshells are there. The two subshells are 2s and 2p. Okay, 2s angular momentum quantum number value L is equals to 0. 2p angular momentum quantum number value is 1. Okay, N is equals to 2 means in the two subshells are there. What are that? 2s, 2p. 2s that L value is 0, 2p that value is 1, like that. So by depending on the elliptical orbit, Sommerfeld proposed this azimuthal quantum number. This is also called as angular momentum quantum number. So this is okay. This is shown by L, means this is explaining in each main shell subshells are there. In each main shell subshells are there. About that this will explain. Okay, and this is showed by L. These L values are start from 0, 1, 2, 3, 4, dash 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 like that. Okay, so if the if L is equals to 0, then the name of the subshell is S. If L is equals to 1, the name of the subshell is P. If L is equals to 2, the name of the subshell is D. If L is equals to 3, the name of the subshell is F. Like that it will be present. Okay, if N is equals to 1, there is only one subshell, and that L value is 0, and that name is 1s orbital. And N is equals to 2, there are two subshells. Okay, what are the subshell? 2s subshell and 2p subshell. 2s subshell L value is 0 and 2p subshell L value is 1. Now we will discuss about azimuthal magnetic quantum number. This magnetic quantum number is showed by M. Okay, this magnetic quantum number is proposed by Landé. So this is showed by ML. Okay, this magnetic quantum number ML has integer values between -L and L including 0. Means these values will be present like this: -L, 0, plus L, like that it will be present. Therefore, certain value of L, there are 2L plus 1 integer values of ML as follows. So here these M values are depending on the L values. These M values are depending on the L values. Okay, means magnetic quantum number ML has integer values between -L and L including 0. Thus for certain value of L, there are 2L plus 1 integer values ML as follows. These values describe the orientation of the orbital in space relative to the another orbital in an atom. Okay, when n is equals to 0, if we substitute this in the 2l plus 1, then what will come? The place of l 0 substitute 2 into 0 plus 1, 2 into 0 0 plus 1, 1 means if l is equals to 0, in that only one orbital is there. Okay, what is that orbital? 1s orbital. Okay, so that's why in S only one orbital is there. So this magnetic quantum number is proposed by Lande. Okay, so this is showed by MRML, and this is explaining about the orbitals. This magnetic quantum number m values are depending on the magnetic quantum number values m all are depending on the angular momentum quantum number values. Okay, so means అదే ఇప్పుడు ఇప్పుడు వచ్చేసి కనుక పంట ఒక 10 నిమిషాలు అయిపోతుంది. ఆగే చేది 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 జల్ది जमे जल्दी है जरा आगे माइंड जाने मुंदी तुझे बोले if L is equals to 0, L is equals to 0 means which subshell? That S subshell that we discussed in angular momentum quantum number. So this L is equals to 0, substitute in 2L plus 1 formula. Why? Because M values are depending on L values, no? So that's why this L is equal to 0, substitute in 2L plus 1 formula. So in the place of L substitute 0, what will come? 2 into 0 plus 1. 2 into 0 plus 1 means what will come? 0 plus 1 means 1, means if L is equals to 0 means that is the S subshell. In that S subshell only one orbital is there, that is 1s. Okay, means in S orbital one orbital only there. Next, L is equals to 1 substitute. L values are start from 0, 1, 2, 3, 4 like that, no? 0 we are substituted. 0 we are substituted, then what is came? When we substitute the 0, in that only one orbital is there, that is S orbital. Next, when n is equals to 1, L is equals to 1 substitute. L is equals to 1 means what is that orbital? P orbital. Okay, this L is equals to 1 substitute in 2L plus 1 formula. Then what will come? 2 into 1 plus 1. Okay, actually like L is equal to 1 means that is P subshell. Substitute that value in 2L plus 1 formula. What will come? 2 into L. L means 1, no? 1. 2 into 1 plus 1. 2 into 1 2. 2 plus 1 means 3. Okay, so that means this ML has 3 values. This ML has 3 values that name Px, Py, Pz. Okay, when L is equals to 1, L is equal to 1 means that is P orbital. If you substitute this L is equal to 1 in 2L plus 1 formula, what will come? 2 1s are 2 plus 1 is equals to 3. 3 name, okay, 3 orbitals will come. That orbital's name Px, Py, Pz. And what are its ML value? ML value will be there like this, no? Minus L, 0, plus L, like this will be there, no? So here L is nothing but 1 we substituted. So what are this M's value? Minus L, 0, plus L. Like that it will be present, and these are called as Px, Py, Pz. Okay. Next, L is equals to 2 substitute. Okay. L is equals to 2 means what is that subshell name? D, that we discussed in Ajmutal quantum number. L is equals to 2 means that subshell name is D. So that L is equals to, substitute in 2L plus 1 formula. What will come? L is equals to 2, no? So then substitute in 2L plus 1 formula. Then what will come? 2 into 2 plus 1. So 2 into 2 plus 1 means 2 2s are 4, 4 plus 1 means 5. That means ML has 3 orbital. Okay, so in that how many orbitals are there? In D subshell 5 orbitals are there. Okay, why? Because L is equals to what we are substituted? L is equals to 2 we are substituted. L is equal to 2 means that is D orbit, D subshell. So L is equals to 2 substituted, no? Then what will come? 2 into 2 plus 1. 2 to the 4, 4 plus 1 is equal 5. That means in that D orbitals, D subshell, 5 orbitals are there. What are that? dxy, dyz, dxz, dx square minus y square, and dz square. These are the 5 orbitals will be present in that. And what are its ML value? Minus 2, minus 1, 0, plus 1, plus 2. Like that it will be there. Means this magnetic momentum quantum number is simply explaining in each subshell how many number of orbitals are there. Okay, this magnetic quantum number is simply explaining in each subshell how many orbitals are there. Subshells are shown by letter L. Okay, subshells are shown by letter L. L values are start from 0, 1, 2, 3, 4. Okay, so there's L is equal to 0 means that is S subshell. L is equal to 1 means that is P subshell. L is equal to 2 means that is D subshell. And L is equal to 3 means that is F subshell. So in that each cell how many number of subshells are there, that we can know by depending on the 2L plus 1 formula. Okay, 2L plus 1 formula we depend on, means this magnetic quantum number values are depending on the angular momentum quantum number values. Okay, so the number of Mn values indicate that the number of orbitals in a subshell. This number of Mn values indicate the number of orbitals in a subshell. Means this ML value is explaining about the number of orbitals which is present in subshells with a particular L value. Okay, orbitals in the subshell that belonging to the same main shell has same energy. Okay, fill the table 1 with the number of orbitals per subshell in by 2L plus 1 rule. Okay, fill this table 1 by depending on the 2L plus 1 rule. Then S orbital only, S subshell only 1 orbital is there, that is S. P shell only 3 orbitals are there, Px, Py, Pz. D orbitals, D subshell 5 orbitals are dxy, dyz, dzx, dx square minus y square, dz square. F subshell also 7 orbitals are there. Okay, here S orbitals are in spherical shape, P orbitals are in dumbbell shape, and D orbitals are in double shape. And we will discuss about the